Hey, also, this is the Math 095 review video for the first exam. And so starting off with 7.1 and 7.2. 7.1 was reducing rational expressions to lowest terms. That's where we just had a single fraction. 7.2 is multiplying and dividing with the rationals. And the steps on all of that is the same. It's just factor and then cancel. If there's division, remember you have to flip over the second fraction and do the reciprocal and then multiply. But it's still just factor cancel. And so that's pretty much what this is saying right here. And 7.1, something to point out about that, in 7.3 and 7.4, the last step of those problems is 7.1. It's this reducing idea. So we'll see that again in later sections. All these little boxes, by the way, are on it's page 41 in the notes. And so there's a little cheat sheet in there. You do not get this for the test, so that's not what it is. But what it is a summary of the chapter and kind of how the problems will look and then what the steps are. This would be a really good thing to throw on like a little 3x5 card and throw, okay, math over math. How do I do that? Okay, I factor, I cancel on the back side. So you can kind of recognize the form and then what your steps are for that form. Because what happens a lot on this exam is that people, they're doing steps but not maybe for the problem that they're actually doing, if that makes sense. So they're kind of getting things mixed up between what the problem is and what the approach is to solving it. And it's kind of that it all just turns into a big wad of fractions on the test, and so being able to distinguish them is going to be a big part of succeeding on it. Okay, so for 7.1 and 7.2, these are our factor cancel sections. And so we want to just start factoring stuff first. In this numerator, I notice I'm going to do some scratch work up here, and then I'll put it back together down here. So here I can take out a 5, and that's going to leave a 4x squared minus 9, and then that's a difference of squares. So I'll bring that down here where I'm going to put my answer. That's going to be 5, and then 2x plus 3, and 2x minus 3. So that's our a squared minus b squared, so a plus b, a minus b. This one I can also take out a 5, so I'll do that over here. So that's going to leave a 2x squared, a minus x, and then 5 out of 15 would leave a 3. And then that's 3 terms doesn't leave with 1, so we're going to factor magic method. So 2 times negative 3 would be negative 6. Multiplies to negative 3 adds to be multiplies to negative 6 adds to be negative 1. So it's going to be negative 3 positive 2, 2x minus 3, 2x plus 2. Sorry, I think someone's going to get that alarm. And then I can cancel out the 2's because we got that fake 2 floating around for magic method. So that's going to be, I'll just write it down over here. So 5, 2x minus 3, and then right here this will be x plus 1. So 2 into 2 for 1, 2 into 2 for 1. And then we kind of look at what we got, and if we have the same thing top and bottom, then we cancel. So I got 5's that can go, and then 2x minus 3's that can go. And then what's left, 2x plus 3 and x plus 1, so that's my answer. Okay, so the second problem, we have 4 terms, so we can just do that by grouping. Out of these first 2, I could take x squared. That's going to leave me an x plus 5. And then if I want to get x plus 5 again, which I need to because that's how we're going to do the grouping, I would need to take a negative 4 out of those. And the negative 4x right there, negative 4 times 5, there's negative 20. And then remember that this right here becomes our common factor, so we pull that out front. X plus 5. It leaves behind the x squared and the minus 4. And then that's a difference of squares. So that's going to be x plus 5, and then x plus 2, x minus 2. And then here, this is 3 terms, and these are the 1s, so we just have what multiplies to be 10 adds to be 7. So x plus 5, and x plus 2. And then we just cancel our 1's, so x plus 5, and x plus 2, x plus 2. So final on that is x minus 2. Okay, number 3 is a division, so we're going to have to flip this. I'm just going to do it as I'm factoring. So this one is what multiplies to negative 18 and adds to be positive 3. So x plus 6 and x minus 3. What multiplies to be negative 24 and adds to be positive 2. So x plus 6, x minus 4. So rather than divide, we're going to write multiply and then flip over the fraction. So that's now my numerator. And that is 2 terms with cubes, so it's that formula one. So it's going to be x minus 4. And remember, we go x times x squared. What I did was I just what times what for x cubed. And same thing, 64. And then x times x for x squared, x times 4, opposite sign. So 4x, and then 4 times 4 for 16. And then this is my denominator, and then here, notice there's a common x, so I'm going to pull that out, and it's going to leave x squared minus 9. And then that's another difference of squares. So that's going to be x plus 3, and x minus 3. So let's get rid of x plus 6's, x minus 4's, and x minus 3's. And so it looks like this part right here, what's left would be my answer. Okay, so questions 4 through 7 would be to you guys in class. So this first one's 7.1, and we got a couple of GCFs going, so I'll pull those out first. The numerator, I can take a 3 and an x, so that's going to leave me an x squared minus 4. And then on the denominator, it looks like 6 everywhere, and then I have an x to the first, so 6x. And that's going to leave me an x squared minus 4x, and then plus 4. And then both of these are going to factor a little further, so we'll go 3x, difference of squares, so x plus 2, x minus 2, and then the 6x up there. And then this I could write one of two ways. I could write it, it's going to be what multiplies to 4 and adds to be negative 2, or negative 4, so it's going to be negative 2, negative 2. So I could write it with the squared notation, but when I'm canceling, I kind of prefer to actually write it out, just because it makes the canceling easier to see. So let's see, we can get rid of a couple minus 2's there. We can get rid of those x's. And then 3 over 6 is the same thing as 1 over 2. So I can think of it as 3 goes into 3 once, so I don't really need the 1. And then 3 goes into 6 twice. And so it looks like what's left would be x plus 2 up top. And then downstairs I got the 2, and then just that x minus 2. Number 5 is a couple of 4-term problems, so these are going to be factoring by grouping. So I'm just going to do them in place with the fraction bar, and it's this top is going to do, let's see, we have a common x, so I'm going to pull that out front, and then we're going to have an a and a plus 2 left. And here I could take out a 3, and that's going to give me the same a plus 2. I can kind of double check 3a and then plus 6 is right. Here I could take out a y, and that will leave me a plus 2 again. And then to get that same a plus 2, because that's going to end up being my GCF on the next step, it helps if you kind of look at this and go, okay, I'd have to take out a negative 4. And then double check yourself by kind of distributing back, and you get the negative 4, 8 minus 8. Here, although we'd get the same answer if we canceled these a plus 2's, we shouldn't. We should finish factoring first. What will happen a lot of times is like this will be an x over an x, and I'll see people cancel, and cancel those x's. So even though these were going to cancel in a second, the x's wouldn't, because they're actually attached to the 3 and the 4 here. So we'll finish our factoring by bringing the a plus 2 out front. leaving behind x plus 3. Same idea downstairs, so a plus 2, and that will be x minus 4. And then I can legit cancel these because everything's factored. And so then x plus 3 over y minus 4 would be the final answer on that. Okay, number 6. So this is just a bunch of 3-term, kind of relatively easy factoring. So these are all going to be the 4 multiplies to this adds to be that. So this would be a x minus 1, x minus 7. Down here we need to multiply negative 4, add to be 3, so x minus 1 and x plus 4 gets me my negative 4, my positive 3. And then for negative 10, we'll do a 5 and a negative 2. And then for a positive 14 and a negative 9, I'd need negative 2, negative 7. And then we'll just cancel and see where we end up. So minus 1s are gone, minus 2s are gone, minus 7s are gone. So it looks like just x plus 5 over x plus 4. Okay, number 7. So this one's a divide. So as I'm factoring, I'm not gonna rewrite it all, but I'm gonna flip it kind of in my head and then factor accordingly. So this first piece up here, it's our very basic difference of squares. X plus 1, x minus 1. So a squared minus b squared. A plus b, a minus b. This gets people. So people try really hard to make this do what this just did, and they miss the GCF. So the GCF on this would be a 10 and an x, and then that's it. That's all it does. So be careful not to fall for kind of the easy, that's a, in quotes, easy, GCF, the greatest common factor. Because sometimes that's all they do, and people will try so hard to make it do other things. So I'm going to rewrite this as a multiply instead of a divide, so that makes this come upstairs and this will be downstairs. So I'll start with the x cubed plus 1. That is a sum of cubes. That's that a cubed plus b cubed formula. So that's going to look like x plus 1. And this was section 5.5, if you need to review that at all. And so we go x plus 1, x times x for x squared, x times 1 for x, opposite sign, 1 times 1 for 1 right there. And then this is up top, and you can kind of see that 5x everywhere, so we can pull that out of there. 5x, and that's going to give me x squared minus x and plus 1. And what will happen sometimes is people will try really hard to make this factor further and not realize it's there to end up knocking out that piece of the cube that doesn't factor. So the problems that have cubes in them, remember that you can end up with that trinomial that isn't going to factor. So those cancel. Plus 1, we can get rid of that. We got x's in both spots, we can get rid of those. We got x minus 1s are gone. So I'm left with the 5 and the 10 right now. And so if I think of that as, it's just 5 over 10, reducing my fraction, and I get 1/2 as my fully reduced answer. Okay, so sections 7.3 and 7.5 are probably, well, they're 2 of the 3 hardest sections on the test. Generally, people end up pretty okay in 7.7, and as long as you got the factoring down, 7.1, 7.2 aren't too bad, because it's all just the same steps, factor and cancel. But 7.3, 7.5 are trouble for sure, and 7.4 sometimes gives people some trouble. But these look so much like one another. I think what happens is people kind of mix up the steps because the problems are pretty similar looking. They both often would have addition and subtraction going on. It's just one you're adding and subtracting, and the other you're doing basically like there's an equals and you're solving. And so I'm going to start with the 7.3 and kind of talk about what the steps are for that. So I'm just going to do a really basic little fraction problem down here. 1/2 plus 1/3. and kind of go through these idea of adding, subtracting fractions relative to these steps. So for 7.3, there's no equal signs. No equal signs. It just kind of looks something like this. So you can't clear fractions, because like this, I can't just multiply it by 6 and say, so that give me 3 plus 2, and magically now this is 5. Like, that's super not legit. So no clearing fractions, and you're simplifying. You're just trying to get it down to a smaller chunk of math. You're not solving. You're not going to get like a satisfying x equals 3 or something at the end. So the steps are: 1, factor the denominators, identify the LCD. These ones are prime, so I could just multiply them together, and my LCD would be 6. And so then step 2 is multiply the fractions by the missing pieces of the LCD. So 6 is 2 times 3, so the 2 needs 3's, and the 3 is going to need 2's. And so remember that you're multiplying by a clever form of 1, right? Because we can only multiply individual pieces by 1's. And then, like I said, from the 6, the 2 is missing the 3, so I'm giving it the 3's. The 3 is missing the 2, so I'm giving it the 2's. And don't clear the denominators, so that's that clearing fractions. So cleaning this up and writing it a little bit better, I get 3/6 plus 2/6. And then collect terms in the numerator, so I can write this as a single fraction, 3 plus 2 over 6, and then combine these and get 5/6. So that's collecting terms in the numerator, and then factor the numerator, reduce. 5 is prime, so it doesn't factor, it doesn't reduce with the 6, so I'm done. But that would be a step like if I got 8/10 or something, I'd have to think of it as 2 times 4, 2 times 5, and that's that section 7.1 factor cancel idea. So we factor our denominators, we multiply them by what they're missing, we collect up the numerator, and then we see if we can cancel. So that's how we do 7.3. Okay, so first example for 7.3. So step 1 was to factor the denominators, and the numerator does factor, but we don't really want to do that because we're going to end up having to multiply it right back when we go to collect things. So even though I could take a 2 out of here, there's not a good reason to, so I'm not going to. Here I can take a 3 out, and that's what I'm supposed to be working on, is the denominator. This is already what it is, so I'm just going to write this piece over here. So my LCD is going to be 3x plus 4, because that's kind of what I have going. And then I'm going to multiply this one by what it's missing, which is this one's 3. And a lot of times you're going to write this the same way I just did with these 3's on the other side. It makes people do bad math, and it's so much easier than trying to like scrunch stuff in here, which also makes people do bad math. But I really encourage you to do this step I'm doing right now, which is, so the 3, it would be much more comfortable distributing it from the front. And then notice this negative. So that flips that to a negative 3 times x minus 2. And the denominator, you don't need it until you're going to cancel stuff at the very end. So I just write LCD down there. But if you write this line out good, you're so much more likely to get that distribute right and get the positive 6 here rather than the negative 6 that a bunch of folks are going to get. And that right there is the most common error. Well, okay, so either not having a clue how to do it, that's sort of one thing that happens on the test. But in terms of people knowing what they're doing, where they make an error is right there and getting a negative 6 instead of positive. So we'll do our distribute, minus 3 times x, and minus 3 times minus 2 for that plus 6 over the lowest common denominator. I'm going to sneak up here with it just so I have enough space. So 4x minus 3x is going to be x. 2 plus 6, oops, I don't think I needed much more space, was going to be 8. And my LCD was 3x plus 4. That doesn't cancel. You can't, this would have to be an x plus 4 up here, or this would have to be an x plus 8. So you can't like do the x's and go 4 and 8 or something, because it has to be the exact same factors. So that is as far as that one will go. Okay, number 2, let's see, I'm going to write the factored version over here, and again, just trying to have enough space. So x plus 7, this would be 2, and then x plus 6 plus, over here I have 6, and then x squared minus 36, that's x plus 6, and x minus 6. So my LCD is going to be a 2, an x plus 6, and an x minus 6. So this one would need the x minus 6. So we slip that in right here. And then this one would need the 2. And so LCD, you just toss it up here, was 2x plus 6, x minus 6. So that's making everything come out 2. And then I'm going to rewrite my numerator decent so I can see what I got. So I'm going to have x minus 6, x plus 7, and then that plus right there. 6 times 2, go ahead and write down 12. And then I don't need this stuff yet. Here's why I don't like writing it. One, I don't like writing it, and just having to write it all. And two, people then see these x minus 6 that you just put in, and then they go and cancel them back out, which isn't legit, because it's this plus right here makes this numerator not factored. So you can't actually cancel here. So that's why I usually just write LCD. Here we'll FOIL, so x times x is x squared. I think for the sake of space, I'm going to say x times 7, that'd be 7x, and then minus 6x is going to be, actually, I'll just write it out because we need one more line anyhow. 7x minus 6x, that would be a minus 42 on the end, and then plus 12. And now I'll just do LCD. Collecting my like terms and writing in descending order. Down 42, up 12 is going to be minus 30. LCD, and then I can factor that numerator, so that means it's probably going to reduce. And so right here we're at that last step where now I have this over this denominator, and I have to see if there's anything common between them, so I do that by factoring, just like in 7-1. So this is going to go x plus 6 and x minus 5, which will give me negative 30, positive 1. And now finally I'll bring this back. Because until this very last step where I factored my numerator, I can't cancel until right there. So if you're trying to cancel anywhere earlier in the problem, it's not good. Should be at the very end. So x minus 5, 2, x minus 6. And actually I should temper what I just said ever so slightly. Sometimes if there's a GCF, you can cancel that, but the amount of not good canceling I see, I would just say again, make sure you get all the way factored before you cancel. It's just a safer bet. Okay, so this one, x minus 2, so I'll factor this, x plus 1, x plus 3, that gets us the 4, minus x minus 1 over x, that'll be plus 2 plus 3. Okay, so this one's going to get kind of big for a second. We got plus 1 plus 3 plus 2, so that's going to be our LCD. This one's going to need the x plus 2's. And this side is going to need the x plus 1's. So this is going to be x plus 2, x minus 2 minus x minus 1, x plus 1. When you have a FOIL like that with a minus in front, a really good way to think of this is like that. Because you're going to FOIL this stuff out, collect it all, and then that minus has to distribute through, so there's kind of two separate steps. If it's more comfortable, you can write back here. You can also think of this right now as x squared minus 1 if you did your FOIL out here, and then when you bring this in, you just throw a parenthesis in front of that. So either way. So we got LCD right there. If you FOIL them out right, you're going to get x squared and then minus 2x plus 2x, those cancel. So we're getting that difference of squares, which is x squared minus 4 minus, and then that little bracket, that will be an x squared minus 1, LCD. And then distribute, And let's see. Okay, well those cancel. That's nice. And I'm left with negative 4 plus 1, so that is negative 3. And then just write down the LCD and that'll be it. X plus 1, X plus 2, X plus 3. Okay, so next up is the 7.5 example. So these are the equations. They have equal signs and they say solve in the directions rather than simplify. So I'm going to do the same problem I did last time. I'm going to do 1/2 plus 1/3. But this time I'm going to change it up and I'm going to say equals x. And so I'll use this. I've made up an equal sign. So that makes it an equation. I can use these solve steps. So if I was going to do this problem doing this, use the LCD for all denominators to clear the fractions. Okay, so I got 2 and 3. So my LCD is 6. So we'll do a 6 on both sides. We can think of that as 6 over 1 if it's helpful. And then I'm going to cancel these fractions. 6 over 2, that would make 3. And then 6 over 3 will make 2. And this side will be 6x. If linear, get x's to one side of the equals and numbers together and solve. If quadratic, set to 0. So do the x squared plus whatever equals 0. And then factor and solve. The last thing on these is we have to check all solutions for division by 0. So here, this one came out linear. It was 5 equals 6x. And if I have 5 equals 6x to finish solving, I divide both sides by 6 and get 5/6 equals x. Okay, so this was just that showing how to cancel step. If you compare that to what I did before, so this is, 7.3, and this is 7.5. Here we had to multiply by 1 when there's no equal sign. Here we multiply both sides by 6, which is really the same thing as multiplying by 1, because if I divide this 6 over, I get 6 over 6 is 1. But here I had fractions all the way through, and I just got down to a simplified number. Here, the fractions drop out after the very first step, because that's what we're doing, is clearing the fractions. And then we're solving what's left, and I end up with something that has, x equals that number, which makes it a solve rather than just a simplify. So hopefully those two fairly simple examples will kind of help you separate those steps in your head. I see people get these mixed up a lot, where on the one without the equals they clear the fractions, which is like super wrong. And then the one with the equals, they'll try to do the multiply by 1, which can work out, but it's a lot more complicated looking, and so people usually get lost somewhere in there. So your best bet is to throw these on a 3x5 card and do, okay, so if I'm adding or subtracting, it's going to look like this, no equals, and then there's your steps. And if you're solving, you're going to see an equal sign. It'll look something like that. And then there's your steps. You're going to clear fractions and then solve accordingly. So let me do some examples with 7.5. So x plus 2, x minus 2. And so now our step on this is that we multiply both sides by the LCD to clear the fractions. And so that's going to get us something with no fractions right at our second line. So x plus 2, x minus 2. X plus 2 and x minus 2. If it helps you can think of it as over 1. The way that I like to think of this is whatever is here is going to be gone, because that's going to cancel. So I'm going to be left with a 3 and then the other piece, the x plus 2. And here, I'll see people try to do all this out in their head. You make mistakes, trust me. If you just kind of write yourself a nice clean line here, you'll do probably way better, because sometimes those little mistakes end up making it where you can't finish the problem. So here the plus 2's cancel, so I'd have 2 and then that x minus 2. Here, the common error that people do is they cancel it, sort of, and then they go 3x, x plus 2, x minus 2. So don't do that. All that's gone, because that makes it really hard. Now it's a cubic. You don't know how to solve those. So careful when everything cancels. It really does cancel. And now this is a pretty friendly Math 94 problem. We'll just distribute the 3 and the 2. So 3x plus 6, 2x minus 4 makes 3x. I got some like terms, so I'll put those together. 5x, 6 minus 4, so plus 2 equals 3x. And then I need to get my x's to one side and my numbers to the other. I'm just going to send this 5x over this way, just so I can do it in one step. I could also bring the 2 and subtract the 3, which would also be fine. And those are gone, so now I have 2 equals negative 2x, and dividing the negative 2, x equals negative 1. This is the place where the restricted values matter, and so when we're solving, we can't have something divide by 0. We can't have a solution that would cause division by 0, I guess I should say. And so looking back at my LCD, x could not equal 2 or negative 2. And so I got x equals 1, so all's good. But if I had gotten one of these, then that's that last step in solving. You have to check for an extraneous solution. And if that were the case, if there's only one answer and say it came out negative 2, then this would be a no solution. If there's 2 answers, then you just dump the one that doesn't work. So it can happen that it has 1 answer, no answers, 2 answers. Just don't know until we solve them. So here I'm going to use x squared, because that is my lowest common denominator. So I'll use that to clear these fractions. So that's going to give me a 4x squared. And here x squareds would cancel, so that's just going to leave that plus 5. And here I have 2 up and 1 down, so that's going to leave me 12x. This one came out quadratic, so I want to get this over to this side. I want to get it set to 0, and I like solving when I have a positive squared term. So I'll sneak over here with it. 4x squared subtracting the 12x gets me minus 12x, and then that plus 5 equals 0. And this is doesn't lead with a 1, doesn't have squares on the ends because of the 5, so I have to do magic. So we're going to do 4 times 5 is 20, so my numbers are going to be negative 10 and negative 2. So this will be 4x minus 10, 4x minus 2 equals 0. Remember, we divide out our fake 2, or fake 4. It's going to come out 2 on both sides. So 2x minus 5, 2x minus 1. And if you do the guess and check version or AC or some other version to get from here to here, that's totally good. You do not have to do what I do. That's just my version. I get these 2 factors, so I'm going to set them to 0. And so I bring my 5 over. And on this side I get x equals 5 halves. Same thing on this side. And I'll just jump down, plus 1 divided by 2, so x equals 1 half. The bad number in this case would have been, I just had plain x's downstairs, so x could not have been 0. And I did not get that, so all is well. Okay, so this one, you gotta do a little factoring to see what's up. X plus 5. And then here, this is that one where, again, people try to make it x plus 2, x minus 2, but it's got a common factor of x. So it's really x minus 4. And then this side is 18, x squared minus 16, so that's x plus 4, x minus 4. And that's a good spot. Like when you get these plus minus 4s over here, if you had done the thing where you did x plus 2, x minus 2, and all of a sudden you have like 4 factors, and it's like they're all different, which is way harder than we've seen on the homework. Go back and check and try to see if there's something, if it seems too horrible to be true, double check the factoring. So here the LCD is going to be x plus 4, x minus 4. I don't have a ton of room, so I'm going to just kind of cheat here and write LCD on this side. And let me write it out, even though it's going to be 0, just so you can see x plus 4, x minus 4. I'll kind of point at that as I'm doing the canceling, since I don't have enough room there. So here I'm going to have x plus 5 in the numerator. The x and the x minus 4 are canceling, so I'm going to have that plus 4 left. Minus 18. And then the 4s are canceling, so I would have the x left. Again, this is like, think of this thing right up here by the 18. So then all that's canceling, and it's just 18x. And then on the other side, 0 times all of that is still 0, right? So this is just all knocked out. And then we'll do a little FOIL, so x squared plus 4x plus 5x plus 20 minus 18x equals 0. Collect our terms, so x squared, 9 minus 18 would be minus 9x plus 20 equals 0. So x, so it looks like a minus 4 and a minus 5 would give me the 20 and the negative 9. And then I have solutions of x equals 4 and x equals 5. Except back here at the start, if we look at the denominator, for an x in front, that means x cannot be 0, negative 4, or positive 4 for this one. And I got 4, so I got to make sure I dump that one. And then that's my legit solution right there. Okay, these next 6 problems are the ones I would have you guys try in class. So if you're watching along with this, you can shut off the video and pull up the notes. Give them a go, use it for practice. And I would really encourage it on these 6 because these are the questions along with 7-4, but these are the questions where people have trouble. So it's a very good spot for you to actually stop listening to me do math and do some math. So hopefully you shut this off and you go try these, and if you get stuck, then toss the video on and see how to do it. I'm going to go through these a little bit faster just because this video is going to get super duper long and there's 6 of them. So I'm going to go a little bit quicker on these ones and not do quite as much explaining. So for number 7, the thing I guess I should explain is I look at this, I don't see any equals. So that means we're in 7-3, so I'm going to multiply by what it's missing. First step is to factor the denominator for either section. But then it's right here where we have to decide, okay, so what am I doing? And so there's no equals, so that means I need a common denominator so I can add the numerators. That's going to be an x minus 5. So x minus 5, I guess I'll do that, x minus 5. So this is going to be 5, and then 1 times x minus 5 is just going to make x minus 5 over x minus 5. So careful not to cancel these because we have not collected terms yet. So if there's anything left to do, then don't cancel yet. 5 minus 5, so I put those together, and then I have x, because these cancel over x minus 5. And then here, these x's cancel out, and that's where it's legit. So a lot of times people write down x minus 5, which it's not. This is like times an invisible 1, so it'd be 1 over x minus 5. So it's the same idea as if I have 5/10. It doesn't make 2, it makes 1/2, right? So we still need that placeholder 1 up there. Okay, number 8, this one has an equals, so let me rewrite it. And so with an equal sign, that means we want to take the LCD, which is x minus 3. We don't want to do that here and start trying to put stuff together. We just want to kill off all the fractions. So x minus 3 on both sides. And you can get there that other way, but people almost never do, so I wouldn't encourage it. So this is going to be 2 times x minus 3. Here the x minus 3's cancel, so I'm left with that plus 3. Here these cancel, so I'm left with just the x. So let's see, this is going to be 2x minus 6 plus 3 equals x. Collect terms. 2x minus 3 equals x. I'll bring the 3 over and the x over. So subtracting the x will leave x, and then adding the 3 will be 3. But the trouble is the one bad number here was x doesn't get to be 3, which is what I got. And so this is not true, and it's a no solution. Or on the computer you would have written does not exist, and that's fine too. Okay, so this one isn't equal, so we're going to clear fractions. So we're going to do x squared. You can think of that over 1 if it helps. So x squared times 1 will get me x squared. X squared up and x down will leave an x in the 5. Here they just cancel, leaving 24. And then I'm going to subtract that 24 over because it's quadratic, so I want to get it equal to 0. And now I can factor and solve. So we'll do x is what multiplies the negative 24, adds to be 5 is going to be plus 8 and minus 3. So here we get solutions of x equals negative 8, x equals 3. The bad number was x couldn't be 0, so all is well there. Okay, number 10, no equal signs, so we're going to factor our denominators and then multiply by what's missing. So 3x minus 5. This is the kind of thing, yeah, this is that too easy, it's hard thing again. It's really easy to miss the 2 and then start multiplying this side by the x minus 1 and this one by the 2x minus 2. But it's a much easier problem than that. And so super important that you look for those easy little GCFs, again, that's easy in quotes, because now I just have to do this by 2 and that's going to make for an easier problem for me. And so this side needs that 2. And again, this is where it's really good if we rewrite it. I was just thinking about probably in the, I imagine in the first video I did the analogy of my kids in the backseat getting jealous and that fractions are jealous. So when you're adding and subtracting, that's the jealous fractions where you have to give them both the same thing. When you're solving, that's where you just like take everything away. No one gets anything. So this is going to be negative 2 and then x minus 2. And I'm just writing LCD down there. So all I did on that line is just write it with this 2 in front so I can see this a little better and make sure I get that positive 4 coming up. So 3x minus 5 minus 2x and then plus 4. LCD. And 3x minus 2x, it's going to be x minus 5 plus 4 is minus 1. And then that's over 2 x minus 1. And then here I can cancel those x minus 1s. And I get, that reduces down to 1/2. So number 11, no equal sign on this one. So that means we're just simplifying. So we'll do 3x and 10 and 7, so that's going to be x plus 2, x plus 5, minus 2x, and then 8 and 6, so that's x plus 2, x plus 4. Sometimes I'll see people in the test do this, like where they just cancel these, and that's totally not true. You can't do that at all. So resist that urge. What these are, so these are our jealous fractions, right? So this one is jealous, this one has an x plus 5. So we're going to give it the x plus 5 over here. And then this one would be jealous of the x plus 4. And then if I take a second and write that out well, it'll look like 3x, x plus 4, minus 2x, x plus 5, all over the LCD. And if I'd written that out, you know, x plus 2, x plus 4, x plus 5, again, there's that temptation to cancel here. You haven't factored anything. Well, you factored these, but you haven't factored your numerator, so you can't cancel yet. You would still be at distributing and collecting here, but that's kind of the spot where people make an error. 3x times x is going to go at 3x squared. 3x times 4, 12x, and minus 2x squared, and minus 10x. LCD. 3x squared minus 2x squared, that is x squared. 12 minus 10 is going to be a plus 2x, and that's over, again, this LCD. And then I have to check now and see if the numerator factors, which it does. It's going to be an x and an x plus 2. So we got x plus 2, x plus 4, x plus 5. And only there, once I've factored that numerator, that's where it's okay to cancel those. And then what's left there is our answer. Okay, number 12. So we'll do a little factoring. X minus 3 equals negative 2. This side's going to be x plus 3, x minus 3. So looking at this, I want to clear fractions because of the equal sign. So we multiply each side by the LCD. That's x plus 3, x minus 3. X plus 3, x minus 3. So here the x's cancel, the minuses cancel, and I'm left with the plus 3 and the minus 4. So I can actually show that this time. So this and that. Here the pluses cancel, the minuses cancel, so I get negative 2x. I'm going to FOIL this side, and that's going to come out x squared. Minus 4 plus 3 will leave minus x, and minus 12 equals negative 2x. And then I want to add this over because I want to get to 0. And how about while I have the red pen out, I'll point out x cannot be 0, negative 3, or 3. And then I come down here, x squared, that'll be plus x minus 12 equals 0. And then factoring, I'm going to get x plus 4, x minus 3 equals 0. Yep. And so x equals negative 4, or x equals 3. But back here we got x doesn't get to be 3, so this is extraneous, and that one is the real solution. Okay, so that gets us to section 7.4, complex fractions. So this is going to be where our fractions have fractions in them, and we're going to use the LCD to clear the fractions within the fractions, so we'll get it down to just a single fraction, and that first step is the idea. So I'm gonna rewrite this one over here just a little bit bigger so we can see it a little bit better. And this is another one, much like 7.5, if you can just kind of get out of the first step, you generally do okay, but it's this first one that's a little bit tough. So I'm using the LCD, which is x plus 4. You can multiply it to the 1 and to here, same thing down here. And so that's going to look like x plus 4 times the 1. Here they would cancel, but they don't disappear, they leave a 1. Because x plus 4 over x plus 4 is really 1 for any value other than negative 4. And same thing down here, we're going to have x plus 4 times 1. But now this time when they cancel, it'll be minus 1. And so I can't cancel until I've collected. And that would be x plus 5. And this would be x minus 3. So it doesn't reduce at all. So we use our LCD to clear the fractions. That gets us here. We collect all the terms in the numerator and denominator, and then we look to see if it reduces from 7.1. And I'd say this is the other section on the test that, again, people have some troubles with. So it's a good one to take a bit of time to review with. So this one, I think I could write this in place. So x squared is our LCD. And again, you think of it that way if it's helpful. So we're going to go x squared times 1, and that will be x squared. And then here, 9x squared over x squared, these would just cancel, leaving me minus 9. X squared times 1, x squared. X goes into x squared, so that would leave me plus x. So 2 up, 1 down, cancel, leaving 1. And here, x squareds are canceling, leaving me minus 6. So there's that. If you can get out of the first step, now you have a nice friendly little factor cancel from 7.1 left. So x plus 3, x minus 3 for the numerator, and denominator is going to be x plus 3 and x minus 2. So I can knock out the x plus 3's, and then what's left here would be the reduced form of my answer. Okay, so this one, x plus 9, x minus 9, since that's kind of where we have going. And this is a really good spot to kind of realize whatever's here doesn't survive, because that's going to get canceled. So it should end up, you know, x plus 9 minus, since this is plus, that will cancel x minus 9. And you can always write out the big horrible step. It'll take me forever, so I'm not going to do it. But if it's helpful for you, write this in each of the numerators, and then you'll be able to actually see the canceling, the thing that I'm doing in my head. So I'm going canceling these minus 9s. It's going to be 1 times x plus 9. And then that minus is right here. And so anytime I do a minus, parenthesis, right? So we go plus 9's cancel, leaving x minus 9 in the parentheses. Downstairs, minus 9's cancel, so x plus 9. And then plus, don't really need a parenthesis, but I just wrote it, so I'll go with it. Plus x minus 9. And so these are not factored, so we cannot cancel yet. So we got to collect our terms. So I think I'll come down here. X plus 9 minus x, and then minus and minus will make that plus 9. So it's like a negative 1 that's distributing. And here I'll just drop the parentheses because those are silly. And then x minus x would be gone, so 9 and 9 makes 18. And then x plus x would be 2x, plus 9 minus 9 is gone. And 2 goes into 18 9 times, so I can do a little reduce there. I have 9 over x. Okay, these next three would be to you guys. So for this one, we got x and x squared, so our LCD is x squared. So x squared times 1. And this will be x squared over x, so that's going to leave a plus x. X squared times 1 again. And this will be x squared over x squared, so those are canceling, but leaving the 1. And then we're back to 7.1, factor and cancel. Numerator, it's that too easy, it's hard. Let's just take out an x plus 1. Denominator difference of squares, so x plus 1, x minus 1. And we can reduce those plus 1s, leaving x over x minus 1. So number 5, we'll do an x squared again, since that's our biggest power in our denominators. And x squared times 1 is x squared. Here they would cancel, leaving the minus 25. Downstairs, I'm going to get x squared times 1. X goes into x squared plus 3x. And then x squared into x squared, those would cancel, leaving minus 10. So we'll do this, and we'll do x plus 5, x minus 5. And then downstairs, we'll need a plus 5 and a minus 2. And reducing out the plus 5s, and then this would be our solution. Okay, number 6, so x's and a's, so x plus a, x minus a, x plus a, x minus a. So here, pluses cancel, leaving x minus a, plus, minuses cancel, leaving x plus a. And downstairs, pluses cancel, leaving x minus a. And then minus, so that's where we need that parenthesis. X minus a is canceled, so leaving x plus a. So up top, we have x plus x, so that's going to be 2x. And minus a plus a, so those drop out. Downstairs, let me do that distribute, and then I'll collect. X minus a minus x minus a. So that will be 2x, x minus x, those are gone. Minus a, so that's minus 2a. And then here I would cancel the 2's, and that negative's a little sketchy downstairs, so I'll rewrite it as minus x over a. I wouldn't mark it wrong, but again, that either on the x or right in front is the preferred notation. Okay, and last section, this is 7.7. This was primarily long division polynomials. And so we had a couple of problem styles in here. One of them, which is this first one, is the easiest question on the test. And the difference between this and the ones coming up, let me grab one of those, is that plus right there. So if you have addition or subtraction going on, that tells you you're either in factor cancel, but if it's something a little like that, it's going to be long division. But it's the plus or the minus that makes where you have to long divide. When it's a monomial like this is a really easy problem. We can just, I'm going to rewrite this thing. And then I can just do 9xy cubed, 9xy cubed, 9xy cubed. So I can think of it this way. Sorry, that was my cats fighting. You don't have to write this step out, but it helps to kind of for showing the canceling coming up. So here the 9's would cancel. 3 up, 1 down will leave me x squared. 4 up and 3 down will leave me a y. Bring down the plus. 18 over 9, 2, x squared over x, so that leaves me an x. Y to the 4th over y cubed, so that leaves me a y. And then here 9 goes in 27 3 times. X's cancel, y's cancel. So easiest question on the test right there. Again, look for where it's all multiplying downstairs rather than adding and subtracting. And I think maybe I have something in the directions that says like divide the easy way really or something, trying to point out that it's that easy problem. Okay, so this one is less easy. This one is going to be a long division. I could try to factor the numerator, but it fails pretty quickly. It's 4 terms, it doesn't group. I think on the test I actually, hi Squawk, sorry, that's my cat squawking. So on the test I think I have long divide in the direction, so you'll know that you're at that problem. The other thing I do on the test is I always do one where you could do it by synthetic division that I showed in the earlier video, or by long division. So I'm going to show this example both ways, and so you're welcome to do either one on the exam. So the long division way, and we do need long division, so you should know how to do this, because if this had been a 3x plus 2, this I couldn't do synthetic. So get that written out, and then we do, what do we multiply x by to make it exactly 3x cubed was the trick. And that would be 3x squared, so x squareds go over x squareds. So we do our 3x squared right there, and then 3x squared times this, so that'll be 3x cubed, and then 3 times 2 is going to give me plus 6x squared. And then we're subtracting, so those drop out. Those should always drop out. Minus 5 minus a 6 will make minus 11, and that's the danger spot on these, x squared. And then we just bring down this 2x, and we go again. So what do I multiply x by to make it negative 11x squared? Would be a negative 11x, so these should all be lining up. Multiply that, and I got negative 11x squared, and negative 11 times 2 is going to be negative 22x. Minus 11, that becomes plus 11, so that cancels. 2 minus negative 22 is really plus, that's 24x, and bring down the 1. So this is going to need to be multiplied by 24, and 24 times x, and 24 times 2. And that leaves me remainder negative 49. I didn't leave enough room to write it up there, so I'll do it down here. 3x squared minus 11x plus 24, and then I'll go minus 49 over x plus 2. So that's one way to get there. Or you could do synthetic division, and that is equally valid. So as long as this is a 1, and like I said on the test, I always do one where you can do either method. Remember, for this we do the opposite of the denominator, so we're using the 0, the negative 2, that would make it 0 rather than the 2. So we set that up on the outside, and then we just do our coefficients, 3, -5, 2, -1. So the first step is to bring down the 3, because we're always going to match whatever's here. So this will be a 3, and then -2 times 3 is -6, and then we add them. So that makes -11. -2 times -11 is 22. We add and get 24. These should be sounding familiar. They're these numbers that we got, 3, -11, 24. -2 times 24 is -48. It makes -49. And so this is our remainder. So since I went x into x cubed, this has to be x squared. It's always going to be 1 degree less than what you start with. So 3x squared minus 11x plus 24, and then that should turn out to be the remainder. So same thing either way. Okay, number 3. This is basically the same thing as the last one, except it's missing a term. So when I go to set it up, I'm going to have to include an x squared term because there isn't one. So I'll do 0 x squared. Sometimes you get asked, does it have to be a plus? You could use a minus. Minus 0 plus 0 is the same thing. Pluses just look friendlier, that's all. So I'm going to go, what do I multiply x by to get 2x cubed? So that'll be 2x squared. So already I needed that x squared slot to keep stuff lined up. 2x squared times x, so there's our 2x cubed minus 4x squared. And you can see if I had this x here, I wouldn't have like terms, I wouldn't be subtracting from what I should. So this is 0 minus -4 is plus 4. So 4x squared. Now I break down the x. So this would need a 4x to make it 4x squared. So that goes there. 4x times x, 4x squared, 4x times 2, minus 8x. Those are gone. Minus, minus, minus. That's minus 1 plus 8, so that's 7x. And then bring down the 2. And this would have to have a 7. So 7 times x, 7x, 7 times 2, minus 14. And subtracting, I get remainder 16. So this will be plus this time 16 over x minus 2. To do it the other way, which is so much easier, this would go 2, and then 2 missing terms, so 0, invisible -1, and 2. So bring down the 2. 2 times 2 makes 4. 0 plus 4 is 4. 2 times 4 makes 8. -1 plus 8 is 7. 2 times 7 is 14. And there's that same remainder 16, so you can see I'm getting the exact same answer, x squared, x plus 7 plus 16 over x minus 2. Okay, so then these last 3 are going to be to you guys. I think I'm not going to rewrite this. I'm going to go through them a little bit quicker since I just sort of did all the steps on the last 3 examples. So 2 goes into 10 5 times. x4 over x2 will leave me x squared. Y to the 4th, y squared, will leave me a y squared. 2 into 18, so that's going to be 9. X squareds are canceling, and we'll have a y squared left. 2 into 4 minus 2. X squareds cancel, and just a y left on there. So on the test, I probably wouldn't put one with a 2 here, just because then you don't have the choice to do it by synthetic. But it's still good practice for long divisions. Let me show that. So 2x minus 3 into all that. So what do I multiply 2x by to get 2x cubed? Would be a plain x squared, because it already has the 2. So x squared times 2x, 2x cubed, x squared times minus 3, minus 3x squared. Those cancel. -9 minus -3, so that's plus 3, so that's going to be a minus 6x squared. And then minus 17x. So then, what do we multiply 2x by to get negative 6x squared would be minus 3x. And then there's our minus 6x squared. Minus 3 times minus 3 would be a plus 9 right there. but then we're subtracting, so that's going to be, this all cancels. And this is minus 17 minus 9, so that's 3, 6, 26, I think. I have that right? Yep. And bring down the 39. And then what I multiply 2 by to get negative 26 would be negative 13. And so negative 13 times 2 is negative 26x. Negative 13 times negative 3 is 39. And so for this one, it comes out remainder 0. So our answer would just be that. Okay, this last one is an example of a missing term problem, so I'll do both ways. X plus 3 into x cubed minus 4x squared. Notice I don't have an x term, so I'm going to put plus 0x and then plus 8. So x, what do I multiply x by to get x cubed would be x squared. I'll bring along a 3x squared. And minus 4 minus 3 is minus 7x squared. And we bring down, have our funky little 0x. When I multiply x by to get negative 7x squared, so that'd be negative 7x. And so then minus negative, negative, so it's minus plus 7, so that cancels. And here's 0 minus a negative 21 would be 0 plus 21. So that's 21x and then plus 8. So I'd have to multiply by 21. So 21x, and 21 times 3 will be 63. And then the 21s cancel. 8 minus 63 would leave negative 55. So this would be minus 55 over x plus 3. And then just to do it as a, to show the synthetic, if you want to try that way, we'd use a negative 3 because of the positive 3. 1, negative 4, we got that 0, and then 8. So bringing down the 1, then I go negative 3 times 1 is negative 3. Adding, I get negative 7. That was right there. Much easier. Negative 3 times negative 7 makes 21 right here. So minus minus. 0 and 21, 21. Negative 3 times 21 will be negative 63. There's the subtracting, and there's the negative 55. Cool, and that wraps up the exam 1 review.